Okay, almost done with this lesson. Hopefully you found this pretty straightforward so far. Again, this is another kinetic energy one. This is determine the total kinetic energy before and after collision. So let's look at before first. KE before. So before, we're just looking at it's just this bullet is moving. So the previous two questions. We're not looking at the initial when the gun shot it. We're just looking at when it's hitting the block. So we have 1/2. Our mass is 0.050 kilograms. And our speed of the bullet is 300 meters per second. We're going to square that. So 300 squared multiplied by 0.05 divided by 2. The energy of this bullet is 2250 joules. So let's look at the scenario, the first scenario. So when it hit the block and stuck together. So because it's stuck together, we already know it was an inelastic collision. But you can actually see how much energy was lost. So afterwards, they stuck together. So kinetic energy after. This is called KE1. The mass of the block plus the bullet, 2.050, and it was traveling at 7.3 meters per second. Let's go with that. Regardless of what value it is, we're going to see it's significantly less. 7.3 squared multiplied by 2.05 divided by 2. You see a huge amount of energy was absorbed by the block in that collision. Huge. If you think about the other one, when it passes through, that other scenario, so we have 1/2. We have two objects moving actually, so we have the 2 kilogram block. It's moving at 3, I think we found. But the bullet's still moving. 0.050 kilograms, and then it had a speed of, I think, 180 meters per second. So we have 0.5 times 2 times 3 squared. So the block itself, minuscule. Still a little bit, but pretty minuscule in the grand scheme of things. And we get around 819 joules of energy. So clearly we can see in both scenarios, lots of energy was lost. They're both inelastic. That first one that's stuck together, that's a completely inelastic collision.